Okay, so we didn't get into the definitions of converse, inverse, and contrapositive, but when you have a statement in the form of if something, then something else, that's called a conditional statement. A converse of a conditional statement flips it around. So if the original statement was, if you clean your room, then you get allowance, the flipping, the converse is, if you get allowance, then you clean your room. So you just take the first part of the sentence and the second part of the sentence and you flip them. So we had our postulate on corresponding angles, which told us if two parallel lines were cut by a transversal, then the corresponding angles were congruent. This just goes backwards. It tells us if we have two lines that are cut by a transversal, just two, any kind of lines, and the angles are congruent, the corresponding angles, that means the lines are parallel. So you go two directions. So the first direction is if the lines are parallel, that means the angles are congruent. Now this one is if the angles are congruent, that means the lines are parallel. So the two things mean each other. Does that make sense? So what this tells us is that all four sets of corresponding angles need to be congruent. And remember, the corresponding angles are the angles in the same position between the two lines. Then we have what's called the parallel postulate, which tells us if we're given a line and one point not on the line. So here's our line, and here's our point not on the line. Okay. So if we're given this line here, and we're given this point here that's not on the line, there exists exactly one line, so only one line that we can draw through that point that will be parallel to this line that we already had. And if you think about it, it kind of makes sense, because if I just start drawing lines all over the place, only one of them will land parallel. And that's because of the slopes, right? Parallel lines have the same slope, so there's only going to be one line through that point with the same slope as this other line. So if we draw that line, it'll go through like that. Any other line you draw won't be parallel. In addition to the two new postulates, we've got four theorems. Okay. We have the alternate exterior angles converse and the consecutive interior angles converse. So basically we're doing like the converses of all the theorems I gave you in the earlier section. So let me pause this. Okay, so with this one, if I have two lines in a plane, now just because they look parallel, we can't assume they're parallel. Okay, we have to have proof that they're parallel. And along comes this transversal, and we have our angles. Okay, and if you remember, alternate exterior are on opposite sides of the transversal on the outside of the two lines. So what we get is if angle 1 is congruent to angle 8 and angle 2 is congruent to angle 7, then line A is parallel to line B. Okay, then we have the consecutive interior angles converse. Oops, wrong button. Okay, so the consecutive interior angles converse tells us if we have two lines and they're cut by the transversal, don't forget that consecutive interior angles are on the same side on the inside. And some textbooks, our textbook calls them consecutive interior, some textbooks call them same side interior. You can call them whichever one you want. They're on the same side, so if angle 2 is congruent to angle 5, so yeah, not congruent, supplementary, wrote the wrong word. So if angle 2, let me rewrite that. If the measure of angle 2 and the measure of angle 5 is equal to 180, and the measure of angle 3 plus the measure of angle 8 is equal to 180, then C is parallel to D. So when they're on the same side, they're going to add up to 180. When they're on opposite sides, then they're congruent. Okay, so this one's the alternate interior angles converse. So again, we have two lines out in space. Call them E and F. And they come along and they're cut by a transversal, which creates 8 angles. Alternate interior are between the two lines and on opposite sides of the transversal. So you get, if angle 3 is congruent to angle 6 and angle 4 is congruent to angle 5, then E is parallel to F. Okay, remember we had that parallel postulate where it said that if two lines were cut by a transversal and then one angle was perpendicular, then the other ones were also perpendicular. This goes backwards. So we have two lines. Okay, what this is telling me is let's call this one T. If R is perpendicular to T and S is perpendicular to T, then R is perpendicular to S. Basically, it's kind of like the corresponding angles, because if these are both 90, they're corresponding congruent angles. It works the same way. It's just that they're special because they're perpendicular. We want to identify parallel lines. Okay, so if I'm given this following information, angle 1 is congruent to angle 6. So here's angle 1 and here's angle 6. I want to say, okay, what lines does that make parallel? They're alternate exterior, and that they're exterior to Q and S. So that would make Q parallel to S. Did that make sense? Okay. If we talk about 2 and 3, we're here and here. We're alternate interior, and we're interior to Q and R. So we're in between Q and R, so that would make Q parallel to R. So you need to see basically which two lines are the angles touching. Those are the lines you're looking at to see if they're parallel or not. And then, of course, that's in relationship to the transversal. So when you have a 4-line thing like this, it's a little bit more complicated. See if I have enough colors for this. We've got 2 and 8. That green doesn't show up very well, does it? Okay, well, I'll just do this. 2 and 8. These are interior. Oh, I didn't label the lines. Okay, we'll label the lines real quick. These are interior to lines C and D. They're on opposite sides of line B. So line B is the transversal. Okay. And that makes lines C and D parallel. If I look at 3 and 11, I've got 3 here and 11 here. Do you see how they're in the same position to B and A? That makes C the transversal. And that makes A and B the parallel lines. If I say 12 and 14, 12 is here, 14 is here. They both connect to line A, so A is the transversal. They're on the outside of lines C and D. So they would make C parallel to D. Okay, 1 and 15. 1 is here, 15 is here. Do they touch any line in common? No. Because they touch no line in common, they have no transversal in common, so that doesn't tell me any relationship. So you could just write none. But they have to have at least one line that they both touch. That has to be the transversal. If they don't touch the same line at all, there's nothing. They have nothing in common. It doesn't tell us anything. Okay, 8 and 13 add up to 180. They're on the same side of line D. And since they add up to 180 and they're in between B and A, that makes A and B parallel. And then finally, we have 8 and 6. 8 and 6 are vertical angles. Do vertical angles tell us anything about parallel at all? No, they just tell us that two lines are intersecting, so there's no relationship between the lines. Oops, I can't spell. That we can tell. I mean, the only thing we can tell between those two angles is that they're vertical. So we know that B and D are intersecting, but it doesn't tell us anything at all about any kind of parallel relationship. Let's go over these. And on this one, it said to state the postulate or theorem that justified our answer. So I had 3 and 7. That made A and B parallel because 3 and 7 were alternate interior angles, so that's the alternate interior converse. That's what my abbreviations are. And then I had 9 and 11. They're corresponding angles, so I had the corresponding angle converse, and that made A and B parallel again. 2 and 16 are alternate exterior, so that's the alternate exterior converse, and they made L and M parallel. And then we had 5 and 12 add together to make 180, so they're consecutive interior angles, and they made L and M parallel. Did everybody get that? Anybody have any questions on any of that? No questions? Okay. Okay, so we want to find the angle of M, R, and Q. So we want to find this angle measure right here, so that A and B would be parallel. Okay. We have this angle and this angle are congruent because of alternate interior angles, right? So that means that 5x plus 7 is the same as 7x minus 21. We're going to need to solve that. Take the 5x from both sides, and you get that 7 is equal to 2x minus 21. And then you get that 28 is equal to 2x. And you get that 14 is equal to x, which is great. But that's only half the problem. They want us to find MRQ. So this is the first part. Now we have to do the second part. MRQ is 5x plus 7. X is 14. So we have to plug that in. So we get 70 plus 7, which would give us 77 degrees. From here, we could find every other angle in this if we needed to, right? Because we would then know that this one was 77 and this one was 77 and these were 77. And then if we had to find the other ones, we would do 180 minus 77 and you'd get 103. So then you could say that any one of these was 103. So you can find any angle that they ask you for once you know what x equals. Okay, just make sure not to stop at what x equals unless it says find x. If it says find x, you're done. But if it says to find some specific angle, don't stop halfway. We want to find y on this one. Because this is a perpendicular angle, I know that this is perpendicular, and that means that all of these are perpendicular. So I set it equal to 90. Subtract 10 from both sides. 4y is 80. Divide by 4. And then y will be 20. Looking at these next two examples, what would I do with these two expressions? They're alternate exterior angles, which means that they're what? Any guess? You got a 50-50 chance. Nothing? They're congruent, so they're equal. So you'd set it up that way. Now these two are same side or consecutive interior. What do we know about those? No, we don't know that unless one of them has this little box. Okay, if I do this thing, does that help? They're different, so they're going to do what? they're going to add up to 180. So for this one, I'm going to have to add these two together and set them equal to 180. Okay, so even on these, going through and putting the colors in can sometimes help to know how to set it up, like whether or not you want, if they're the same color, they're equal, so you set them equal. If they're two different colors, they're going to add up to 180. And on this one, just like the last one, they're only asking for x, so you don't have to find any other angles. But if you needed to, you could. You plug in x to find one of these, and then that would tell you all the other angles from there. Here I have 7x minus 3x, so that's going to give me 4x. And negative 2 plus 10 is going to give me 8. Oops, plus 8, not equals 8. 4x is equal to 172. So that makes x equal to 43.